Alright, so let's try to find some more efficient ways to graph these parabolas. So let's talk about, we're going to talk about which way they open and a little bit about the axis of symmetry or the line of symmetry, and then some about how to find some of the other key features. So let's start by graphing these on our graphing calculator. Okay, so go ahead and plug these in. And we're going to go to your y equals menu, and then you're going to put this in as y1, y2, y3, y4. You could also do one at a time, but especially if you have the CE, they're color coded, and so that makes them really nice. Let me just show you what they look like plugged in. So go ahead and plug those into your calculator. All right, and then so you can see the color coding here, right? So that's a nice feature if you have the CE. If you don't have the CE, like I don't have the CE, this is an online version that I use that has the CE, but so if you don't have it, it still works. You can do without it. You just have to you might have to do one at a time then, because it's hard to see which one's which. You can scroll over them and it'll tell you in the top corner, I think it's up here, it'll say y1 or y2 or whatever. So, or it'll say the whole function. So anyway, so let's go back. Let's see if we can see these in the same screen here. All right, so let's see. So the blue one, so y1 is the blue one, right? So let me just label these real quickly. So that's y1. The red one is y2. The black one is y3. And the pink one is y4. Okay, all right. So, couple things. Which ones open upward? And if you said y1 and y3, you were right, right? So y1 opens upward here, and so does y3. Okay. All right. Which ones open downward? That's right, y2 and y4. All right. So let's look at the functions themselves here and see if you can look at or find some, I would say similarities and differences between the ones that open up and the ones that open down, right? So what are some similarities between the ones that open up? And the main thing that I see, that I hope you see, is that they have a positive a, right? Their a is positive, or the leading coefficient is positive, right? The coefficient of x squared is positive. So if the coefficient of x squared is positive, they seem to open up, right? And conversely, if the coefficient of x squared is negative, they seem to open down. Okay, so going back to our chart here, so we have upward, right, downward, upward, and downward. Okay, so and we can see that once again aligns with the leading coefficients. If they're negative, opens down. If they're positive, then they open up. Okay. All right. So that gives us a quick idea. I want to talk about one other thing as well. Let me see if I can get this slide here. So here's all the graphs again, and you can pause and if you need to go back and look at these. But another thing I want to talk about is the line of symmetry. Okay, and we'll talk about a couple things, but let's talk about the line of symmetry next. So the line of symmetry. So quadratics are symmetrical, like we saw in the first example, and so basically you can see that there's a mirror image, right? This half, if you just flipped it across the middle, would be the same as this half, right? Like, in other words, you can spin them around this imaginary axis here and they would match up, they would line up on either side, right? Or you could fold your paper at that line and they would match up, right? And my line is a little bit off, but you can see that they'd match up. So this is called the line of symmetry, or sometimes called the axis of symmetry. okay? And you can call it LOS for short, okay? All right, so the line of symmetry is going to be a vertical line that crosses through the middle of a parabola, and we're going to use a term to identify this point here, which is right on the right in the middle, and that's called a vertex. Okay, so the line of symmetry passes through the vertex, and the vertex is the kind of the point at the top or the bottom of the parabola, right, depending on the orientation. So if it opens up, it'll be the top. If it opens down, it'll be the bottom. All right, so that's the vertex. So the line of symmetry crosses through the vertex. So how do we find the middle? Well, let's talk about a couple other key points. We have these 2 points here, which are the x-intercepts, right? Oops, the x-intercepts. And so for the x-intercepts, how do we find those? That's where they cross the x-axis, right? And wherever we cross the x-axis, that's where y equals 0, right? So what we do is for the x-intercepts, we say, okay, where does y equal 0? And we solve for x, right? And so we basically have a quadratic where instead of putting y equals, we're going to set that equal to 0. And we know how to solve those, right? Quadratic formula, factoring. We can use the completing the square method, or we could use the even root property. So if we use the quadratic formula, which we know works every time, then we have x equals negative b plus or minus. And you all probably already said this out already. Okay, so we have that, right? So basically what's happening is when you have something that you're adding or subtracting to both sides, the midpoint is going to be whatever you added and subtracted to, right? So if that doesn't make sense, we can talk about it more in class, but or you can rewind and kind of go back. But if I say 5 plus 2 and 5 minus 2, the middle of those 2 points is 5, right? Because I would have 7 on one end and 3 on the other. The midpoint is 5. So if you add and subtract something to a value, the middle of those 2 values that you get when you add and subtract is the value that you added and subtracted to. Okay. All right. So anyway, don't worry too much about that. In terms of that we can explain it in different ways when we get to class, and have some of you guys explain it in ways that make sense to you. So so I have this negative b over 2a value. If I take out the radical, the term that I'm adding and subtracting, and that gives me basically where that midpoint is going to be. Okay. All right. And so this is actually going to be the equation for the axis of symmetry, or the line of symmetry. All right. Okay, so let's see. Let's fill in some blanks here. Oh, and one other thing that we'll talk about here, and this is probably the easiest thing to find, is how do we find the y-intercept, right? How do we figure out where it crosses here? And it's hard to exactly, yeah, maybe it crosses right there, right? So it looks like it's 2. So if we go back and look at this graph, or so that was the red one. So where do we see a 2 here? Right there, right? Because just like we talked about when we were talking about the x-intercept, we're setting y equal to 0. For the y-intercept, we're setting we're setting x equal to 0. So we're finding f of 0, right? So if I plug in 0 for x, this goes away, like we talked about, and we just get the constant, right? So in this case, f of 0 would be 2, and that makes sense, right? That's consistent with what we thought on the graph. All right. So the y-intercept of a parabola is always f of 0. Okay, whatever your output is when your input is 0, and for parabolas, it's always going to be c, right? If you put 0 in for x's, a and b will be multiplied by 0 and cancel out, and you'll end up with c. All right. Okay. Good stuff. So let's see. So let's fill in this chart, and kind of solidify the stuff that we just learned. So a parabola opens upward if, and we're looking at a for this one. So if you have a positive a, if a is greater than 0. Parabola opens downward if a is negative or less than 0, right? So positive a opens upward, negative a opens downward. Line of symmetry, that is x equals negative b over 2a. All right. Now remember, the vertex point is the tippy top or the bitty bottom. Just made that up on the spot, don't know. But anyway, so the top or the bottom, remember the line goes through that. So basically, if we know what the axis of symmetry is, that's our x, that's also the x coordinate of our vertex point, right? So our vertex point is going to be negative b over 2a, comma, and then our y coordinate is going to be the output when we plug in negative b over 2a. All right? And then the y-intercept of the graph is always going to be c, right? Whatever c is. And c is the x coordinate, but the y coordinate would be 0, right? Or excuse me, I did that backwards. So that's when x equals 0, y will equal c. Sorry about that. All right. So, yeah, freeze the screen. Make sure you get the notes on this. This is all very important stuff. And these are the key features that we'll be looking for at the graph. There's one other one that we'll see on the next slide, okay? So to find the, so we know the y-intercept is at c, which we just talked about, right? So the x-intercepts, we solve the equation when y or f of x equals 0, right? So we're going to plug in 0 for y, and we're going to solve for x, all right? So yeah, it's always easy to find the y-intercept, right? And yeah, it's usually going to be pretty easy to graph. Now the x-intercepts, sometimes we're going to, like we talked about, we can use the quadratic formula. Sometimes we can factor and we'll get rational numbers. But a lot of times if factoring is not possible, then we'll get some irrational numbers, right? And so if the x-intercepts are irrational, you're going to find the appropriate decimal equivalents to plot them on your graph, right? Because it's kind of hard to say where 2 plus or minus square root of 7 over 5 goes on your graph, right? So we'll have to get decimal equivalents so we can know approximately where they go on the graph. Okay.